Chapter 3, Section 3 in geometry is proving lines are parallel. So basically what we're doing is we're taking all the theorems and postulates we learned in the last section and writing the converse of them. So first thing we're going to talk about is parallel postulate. All right, it's 3-3-2 in your book. It's the second one. I feel like it should be written first, so that's why we're doing it first. So parallel postulate says that through a point P, not on line L, there is exactly one line parallel to L. So I have line L here, and given a point that's not on L, there's only one line that can go through this to be parallel to it. So if I click on this, construct parallel line, you see here, this is the only line that can go through that point and be parallel to this one. Okay, so that's what that postulate says. All right, so next one. Okay. Okay, 3-3-1 is the converse of the corresponding angles postulate. So, what does that mean? It says if two coplanar lines are cut by transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So, we have a transversal J here, and it cuts through K and L. I don't know for a fact that K and L are parallel because it doesn't tell me, but I do know that 2 and 6 are congruent. And since 2 and 6 are corresponding angles, I can conclude by this postulate, this converse postulate, that K is parallel to L. Okay? Now, since I know that, okay, delete that real quick, and then delete these. All right. Now let's say that I wasn't told that 2 and 6 were congruent, but instead was told that the angle measure of 2 is 23x plus 38, and the angle measure of 6 was 17x plus 56. By this theorem, or excuse me, this postulate, in order to prove that K and L are parallel, I have to show that 2 and 6 are congruent. And if they're congruent, that means that if I take their two angle measures and set them equal to each other, and then solve for x, I should get a value that when I plug it back in gives me the same angle measure for both. So let's do this. Let's take this, subtract 17x, subtract 17x. That gives me 6x here. I subtract 38 from 56. That gives me 18. I divide by 6, so x equals 3. So if I plug in 3 here, that means that 6 and 2 will be congruent. If I plug in any other number other than 3, K and L will not be parallel because they won't be 2 and 6 will not be congruent. So the x value 3 here is the only one I can plug in to make K and L parallel by the converse of corresponding angles postulate. Okay, moving on. 3-3-3 is the converse of the alternating interior angles theorem. So if two coplanar lines are cut by a transversal, so I have my transversal J here, so that the pair of alternate interior angles are congruent, so 1 and 2 are congruent, then that means the two lines are parallel. So K and L are parallel. Okay? And I would work this the same way if I was told that I didn't know they were parallel and it said 1 was the measure, had a measure of, let's say, 7x minus 3, and 2 had an angle measure of 5x plus 15. In order to make K and L parallel, these two must be congruent. And so I would set them equal to each other. And solve. So 2x equals 18. Divide by 2, x equals 9. So if x equals 9, that means that K and L are parallel. If you plug in any other value other than 9, that means K and L would not be parallel. Okay. Right. Next. Okay. 3-3-4. The converse of exterior angles theorem. It says if two coplanar lines are cut by a transversal, so K and J are cut by L, so that the alternate exterior angles, so 5 and 4 are alternate exterior angles, and they are congruent, then that means that the two lines are parallel. So K would be parallel to J. And I would work this problem the same way I did the other two. If I was given, let's delete this, delete that. If I was told the angle measure of 5 equaled 99 and the measure of angle 4 equaled 13x plus 8, in order for K and J to be parallel, the alternate exterior angles must be congruent. So I would take those and I would set them equal to each other. And then just solve for x. So 91 equals 13x. I divide by 13. X equals 7. So if I plug 7 in, that would make K and J, because this is line J, K and J would be parallel. Okay, only if x equals 7. If x didn't equal 7, then K and J would not be parallel. All right, last one. Converse of same side interior angles theorem. If two coplanar lines are cut by a transversal, so J and L are cut by transversal K here, so that a pair of same side interior angles are supplementary. So measure of angle 2 plus the measure of angle 1 equals 180, and I did that here. Measure of ABD plus the measure of angle EBD, they equal 180. Then that means that the two lines cut are parallel. And I would work this problem just like I did the other ones, except for one difference. Since they're same side interior, that means that they are supplementary. So let's say instead of knowing what they are, it just said the measure of angle 2 is 12x plus 6, and the measure of angle 1 was 21x plus 9. Since they are same side interior, I wouldn't set them equal to each other. I would add them together. And set them equal to 180 because they're supposed to be supplementary, as here. So then that means that 33x plus 15 equals 180. So 33x equals 165. So x equals 5. So if x equals 5, that means that those two are supplementary, and that means J and L are parallel by the converse of the same side interior angles theorem. Any other value other than 5, and these two lines are not parallel. Okay, so that's Chapter 3, Section 3, proving lines are parallel by the converse theorems and postulates.